The following problems were from your textbook. Um, Stewart, Redlin, and Watson. We got to give the credit first to whoever designed these problems. The numbers are starting from question number 23. Now, it's very important to read this instruction in a careful manner. Find all angles. Find, and here's the key, all angles. All angles. Not an angle. All angles. Theta between 0 degree and 180 degree. So between, that means like 1 pi, quadrant 1 and quadrant 2. So if this is a unit circle, I'm looking at quadrant 1 and quadrant 2. So 0, pi here, and pi over 2. The first one is sine of theta equals 2/3. Sine of theta equals 2/3. Okay. Now, if I take sine inverse of both sides, then I will have theta equals sine inverse of 2/3, and that gives me to 1 decimal gives me 41.8 degrees. 41.8 degrees. By the way, it's the instruction to round to 1 decimal. Okay, so where is this 41.8 degrees? It's somewhere in here. Okay, this theta is somewhere here. Notice that between 0 and 180 degrees, there is another theta in here. There's another theta in here. Let me just go with blue. That would give me the same sine value. Well, how do I find that? I say 180 degrees, okay, minus 41.8 degrees, and that's going to give me 138.2 degrees, and those are my two answers. So 41.8 degrees and 138.2 degrees. Let's do another one. The next problem in your textbook, number 24, cosine of theta equals 3/4. Cosine of theta equals 3/4. Okay, well, positive cosine, positive 3/4, and I'm looking again between quadrant 1 and 2. I only have one, because cosine is negative in here, cosine is positive in here. So for this problem, starting from 0, here is pi over 2, and here is pi, I only have one answer. So all I only have to do is put that in my calculator, and so take cosine inverse of both sides, and so I will have theta equals to cosine inverse of 3/4 to 1 decimal degree is 41.4 degrees. And I'm not going to consider another one between 0 and pi because this is positive. Cosine is positive only in quadrant 1. Cosine is not positive in quadrant 2. Let's do one more something. How about something with tangent? Let's look at problem number 26. We have tangent of theta equals to -20. And let me put a unit circle in here. Zero, pi over 2, and pi in here. Now I'm going to go ahead and take tangent inverse of both sides. So I have theta equals tangent inverse of -20. Putting it in my calculator, that gives me theta equals to minus 87.1. Well, negative 87.1 is somewhere in here. It's somewhere in here. That's not the area of interest. The area of interest is between 0 and pi. So I have to find, and I know tangent is positive in here, so that's out of the question. Tangent is negative here between 0 and pi and quadrant 2. Where is my angle? Where is my angle that would give me such that its tangent is -20? So how can I find that? So let's say that, let me grab straight edge. Let's say that if my theta in here, if this is my -87.1, -87.1, so I know the other angle, the other theta is right here somewhere. That gives me the same value. So how do I find that? I'm going to say minus 87.1, okay, degrees if you want, plus 180 degrees, and that gives me positive 92.9 degrees. Okay, so positive 92.9 degrees is somewhere in quadrant 2 and has its tangent is -20. Okay, let's do one last one. Go to the next page. Let's do number 27. I have tangent of theta equals to 5, positive 5. Okay, and the area of interest, once again, is between 0 and pi. And here's my pi over 2. I apologize for my drawing. It's not really up to scale, but okay. Taking tangent inverse of both sides, I will have theta equals to tangent inverse of 5. And so theta equals to 78.7 degrees, which is somewhere, if this is my 90 degrees, somewhere here. Okay. And I know tangent is positive in quadrant 1. Tangent is negative in quadrant 2, so this particular question only has one answer. Well, I hope this short video helped, and thank you.